First of all, I would like to thank CSC coordination team who provides such an opportunity for us to present our research. So today I'm going to talk about environmental and economic assessment of municipal landfill location in Saskatchewan and Manitoba, and my name is Karimi. So first of all, we are going to have a quick review about multi-criteria decision making, falsification, and analytical hierarchy process, and then we are going to talk about the materials and methods that we used in current study, and finally we want to show the results and the interpretations of the results and like different implications that we can have from the outcomes of this research. And I also included an image for you to show that citing landfills is one of the complicated issues during the recent years because of the many restrictions and constraints that you have to take them all into consideration. For example, we have, as you can see here in this image, we have underground wells. You have to monitor the underground water, you have to monitor the liners, and leachate monitoring wells should be also provided, and also the surrounding area should be considered, and like different criteria should be monitored and considered even after closing the landfill. So it is one of the major concerning issues in today's environmental engineering. So as a quick review about multi-criteria decision making, falsification, and AHP method, first of all I want to show that why we want to use multi-criteria decision making. Whenever different constraints and limitations, as I already mentioned, is being aggregated in our question, you have to use the multi-criteria decision making to aggregate all of them to come up with a solution. So regularly happens in the landfill siting because, for example, you want to have accessibility to the roads and network, you want to be out of water reservoirs to somehow protect them from the pollutions, you want to be out of protected areas, you want to be out of public site because sometimes people do not want to locate the landfills in the vicinity of their neighborhood. You want to be out of mountainous areas because of the slope, and you have to be out of airports because of the safety. So once you have those restrictions, you're going to apply multi-criteria decision making tool. But first of all, you have to somehow normalize your variables. So as you can see here, I already included like different type of falsification, and I'm going to explain like the details of these individual methods. We already have short, we have medium, and we have tall falsification membership. So what does that mean? Short means sometimes you want to increase the membership of some criteria in the vicinity of the variable. For example, you want to increase the membership of the places which is close to the road network. So you are going to use the short membership because once you are far away from the road network, you start to decrease the accessibility and decrease the membership. But sometimes it is better for you to be far away from, for example, protected areas. Again, at that moment you are going to use the tall membership grade, because once you are very close to the, for example, protected areas, the membership grade is 0, but once you are going to be far away from the protected areas, the membership grade is going to increase, and then it means that locations could be very suitable for locating the landfills. So these are like different type of memberships here. Once you falsified your variables, you have to start like comparing different variables with each other. For example, protecting protected areas is important, or protecting water reservoirs is important. So in order to come up with a decision you have to start like comparing them in a pairwise comparison method and then apply it as a major constructed method. So once you start like having the pairwise comparison, you are constructing like different pairwise comparison, and at the end of the day you are going to concatenate all of them to come up with the final ranking of variables, which is already included here. So you can see that here this is our study area that we used two provinces, Saskatchewan and Manitoba, which is the prairie provinces in Canada, and we extracted different classes within these two provinces, namely urban areas, forest land, and water resources. But we already have access to other type of classes, but there were no need to apply them within our study area. So as you can see here, we have the water resources that's highlighted as blue. We have the protected areas, but their name is the forest. So we assume that protected areas is the forest, that we want to protect them from the hazardous adverse effects of the landfills. So we integrate all of these classes in together to come up with a one individual class, and we named it protected areas. We already have the urban areas, which is popped up as like small point, red points here, which is Regina and Saskatoon and also Winnipeg. These are the urban areas that we want to, for example, locate our landfills out of these populated regions. And once we already extracted these classes, on the other hand, we have the land surface temperature. So we integrate all of these tools in together to apply the multi-criteria decision making. So this is the like a schematic flowchart of total procedure that we had in our study. So at the left hand side you can see that we have the classifications that is extracted from collection 6 modest land cover. This is a type of product that comes from modest onboard Terra or Aqua satellite. So as I already mentioned, we extracted protected areas, urban areas, and water bodies, and at the same time we extracted land surface temperature from our product. So we concatenate all of them together and normalized, as I already mentioned, as a falsification method by overlaid falsification, which is implemented in ArcGIS for suitability map. And once we constructed our suitability map, we used T-zone polygon based on my timeline satellite imagery and zonal statistics to extract the populated regions. And once we extracted the populated regions, we started to split our major map into different populated regions to assign the suitability ranking for each individual tessellation. So and finally we start to have the interprovincial comparison for Saskatchewan and Manitoba based on their landfill locations. So here is the final results for province of Manitoba and Saskatchewan. However, you can see a significant difference between the suitability map of Manitoba and also the Saskatchewan, and Manitoba is much better suitable place for locating and expanding their landfills, and its suitability basically starts from 0.9 up to 1. However, the majority of landfills located in a place in Saskatchewan, that its suitability starts from 0.8 up to 0.9. And the major reasons behind it would be the major constraints that we addressed in our multi-criteria decision-making system, which is water resources, urban areas, protected lands, and also land surface temperature. So as you can see here, the central part of Saskatchewan recognized to be not suitable, and it is relatively low suitable compared to the southern and northern part of the province. And it means that we already have like the protected areas, like different dense vegetation cover regions in this area that drop the suitability ranking a little bit for this area. However, in Manitoba, the majority of the landfills you can see that's located in the southern part of the area is far away from protected lands, and also the northern part of the Manitoba slightly have higher number of landfills compared to Saskatchewan. So as conclusions, we come up that the method could be applied on coarser scales to score and select most suitable sites. Regions that are far from protected areas, waste resource and populated regions are better suitable place. Southern part of Manitoba satisfies all parameters as already mentioned for locating landfills, and intensive vegetation cover in central part of Saskatchewan lowered the suitability of these lands. And authors would like to thank University of Regina, Faculty of Engineering and Applied Science, Faculty of Graduate Studies and Research, NZERC, and Faculty of Engineering Research Opportunities Fund for providing such opportunity for us to present our work. Thank you very much.